Hello everyone, good morning. It's another lovely Wednesday and today we're going to be having further mathematics. Okay, but before then I want us to look at some of the common math errors or some errors that we might be making. Okay, so this is a simple one, dividing a given number by 0. Okay, and I guess some of us might know the answer here. So when you divide a given number by 0, what's the answer, or what does it give you? Okay, now you need to understand that a number divided by 0, here we're using x to represent any given number, is not equal to 0. Okay, that's a common mistake that we might be making. Any number divided by 0 is not equal to 0. For example, 4 divided by 0 is not equal to 0. 4 divided by 0 is not equal to 0. Instead, 4 divided by 0 is undefined. So we say that when you divide a number by 0, the answer is undefined. The answer is undefined. Okay, so how does this? Why is it important to know this? Now, this is important in scenarios where you're trying to solve or you're trying to simplify algebraic expressions. Now, when you're simplifying algebraic expressions, you may have. Okay, let me just give you an example. So, for example, at the beginning of your simplification, you stated that A equals B, for example. Now, towards your end of your calculation, you get an expression on both sides, A minus B. Okay, remember that you had previously stated that A equals B. Okay, and then you get an expression A minus B on both sides. Now, there's a temptation there to divide both sides by A minus B. Probably when you divide by A minus B, you would get a simplified expression. But when you divide by A minus B in that scenario, you are dividing by 0 because you've already stated that A equals B. So that's an example of a scenario where you need to take notes that dividing by 0 is not 0, or it gives you an undefined value. So in that case, you cannot divide by A minus B. So you need to be careful so that when you're doing these simplifications or you're trying to solve an equation, you do not make such mistakes, okay? Because sometimes you get an answer at the end of a solution and you're like, but I got this answer, how come it's not correct? Sometimes you might have, encountered this problem. So if you've been making this mistake previously, remember that any number divided by 0 is undefined. It's undefined, so it's not 0. All right, so that's that for today's section on common math errors. Let's move on to our topic. So in our last class, we were discussing matrices. So we're going to continue today with matrices, and we're going to introduce just a little bit of determinants. Our major class on determinants would be in our next class, but let's just introduce a tiny bit of determinants today. But we're going to finish matrices today also. So let's just start with a quick review of what we discussed previously. So we talked about different types of operations we can carry out on matrices, like addition, subtraction, multiplication, and on. So we're just going to review one example on addition and another on multiplication, and let's see how we can go from there. So let's assume that we have these matrices that you can see. We have A, we have B, and C. So, and we asked to find, for example, A plus B. Okay, how do we do A plus B? Let's start with that. Remember that all we need to do for addition is add the elements in the corresponding positions. So for example, we have 1 here. It corresponds to 3 because this position is A11. So you add 1 plus 3 together, you add 4 minus 1, you add minus 3 and 2. So you would have something like this if you just take each element and add to the corresponding element in the other matrix. Okay, so if you do that for the two matrices, you would have this as your answer. Okay, if you remember this clearly, you would have this as your answer. Now, we also said that we cannot add two matrices together except they are of the same order. So you cannot add a 2 by 3 matrix to a 2 by 2 matrix. That would not work out. Okay, so take note of that. Okay, let's move on to the second example. We have BC. We're supposed to find BC, meaning B multiplied by C. Now remember that for two matrices to be multiplied, they need to be conformable. We talked about conformability in the last class, how we know that two matrices are conformable. So if you have forgotten that, you could quickly rush back to the previous video and try to catch up with what we last discussed. So we're checking now, and these two matrices are conformable, so let's move on and multiply. So remember, you take the first okay, this is what you get, but let's see how we got that. You take the first row here and you multiply by the first column here. So you have 3 times 1 gives you 3, minus 1 times 4 gives you minus 4, and 2 times 3 here gives you 6. Then you take this same first row again and multiply by the second column. So you have 3 times 3 gives you 9, minus 1 times minus 2 gives you plus 2, 2 times minus 2, 2 times 1, sorry, gives you 2. So you do that again for the third column here and you get your answer. So you keep doing that again. You take the second row here in the first matrix and you multiply by the first column, then you multiply by the second column, then you multiply by the third column of the second matrix. Then you take the third row of the first matrix and you multiply by the first column here, then you multiply by the second column here, then you multiply by the third column here, and you get your answer as you can see below. So if you add everything up and simplify, you should have something like this. So like I said, if you cannot remember this or you're having difficulties understanding this, you could go back to the previous video and try to follow that up before you come back to this. Okay, so let's move on. Today we're going to be talking about different properties of the matrix or of a matrix. So transpose of a matrix. How to transpose of a matrix? When we say transpose, to transpose something. How many of you are musicians? Well, if you do music, you should have heard of the word transpose, or to transpose a piece of music. So it's not so much different from what we are going to do here. So to transpose a matrix, what you simply do is, for example, you have A, capital A as a matrix, and then you want to find the transpose. What that simply means is you would exchange the rows and the columns. You interchange the rows with the columns. So you pick the first row and you make it the first column. You pick the second row and you make it the second column. It's as easy as that. Let me show you. This is the first row, right? You can see we have this now as the first column. Then you can see this is the second row here. We have it now as the second column. So that's that for transpose of a matrix. Okay, so for should I say generality's sake, or to generalize, if A is an m by n matrix, that's if the original matrix has an order m by n, then the transpose there'll be a switch in that order, so it will be n by m. That will be the new order of the transpose of the matrix. Okay, so that's that for transpose. Is very simple. Just interchange the rows with the columns. That's all you need to know there. Yeah. So let's move on to the next thing. We're looking at one example of that. Should I say subtopic that we just discussed. So let's look at this. So you have a matrix C here. Yeah, you have C with the elements 3, 2, 6, 7, 3, 0, minus 4, 5, 1. So you have a matrix C. We want to find, when you see C with a T on top of it, we are trying to say C transpose. So we want to find the transpose of the matrix C. So let's look at how to do it. We'll simply interchange. Remember, we're interchanging the rows and the column. So this will become the first column, this will become the second column, and this will become the third column. So instead of rows, or you could use it, you could do it the other way around. You could say this column becomes the first row, this column becomes the second row, and this becomes the third row. You could use whatever works for you. So, but if we do that properly, we should have 3, this 3, 2, 6 here goes here, 3 to 6. 730 goes here as 730, and minus 451 goes here as minus 451. So it's as easy as that. Very, very simple. Okay, so let's talk about special types of matrices now. Like we said, we're going to be looking at different forms that matrices can occur in. So let's start with the symmetric matrix. Now, from the word symmetry, I believe we're all math students here. Yeah, so at least from grade 9, in fact from grade 7, you would have been talking about lines of symmetry in a shape, right? So when you say lines of symmetry in a shape, that has to do with a line that divides that shape into two equal parts. Okay, so at least I think we have an idea what symmetry means. Okay, so a symmetric matrix now is not too different from what you already know, but it has its own form. So if a matrix A is equal to its transpose, it is said to be symmetric. So in this case now, when you have a matrix, okay, and then you find the transpose of the matrix, and you discover that the transpose is the same thing as the matrix itself, then that simply means that it is symmetric. So let's look at that. So for example, you have A as 3 minus 2 and 1, and then let's try to get the transpose of this. So A transpose now would be, okay, 3 minus 2 minus 2, 1. Okay, so what have you noticed here? I think we all can see that A equals to A transpose here. Okay, so that means that we would say that A is a symmetric matrix. So A is said to be a symmetric matrix. Okay, so that's what symmetry when you're dealing with matrices, that's what symmetry means. The matrix is equal to its transpose. That's what it means. Okay, so let's move to the next one, skew symmetric. Okay, skew is the word that has been added here, skew symmetric. Okay, when you talk about a skew symmetric matrix, what are we talking about? Can you try to figure it out? Can you try to guess what is the difference, or what is added? What is, we said symmetric matrix. A symmetric matrix is equal to its transpose. Okay, so what do you think would be added here when we now say skew symmetric? Okay, let me just tell you. A matrix A is said to be skew symmetric if the transpose AT is equal to its negative. So if the transpose of the matrix is equal to its negative, then it's skew symmetric. So let's look at that. This is how you express that. So AT equals minus A. Now let's look at an example. So we have a matrix A here, and then let's assume we decide to find its transpose. Okay, so we get its transpose and we get this as the transpose. And then we start to notice a pattern. We notice that we have a minus 2 here, and we have 2 here, we have 3 here and minus 3, and we notice that the only difference between these two matrices is that while we can just simply say this is the negative of this, or A transpose is the negative of this. If you look at it properly, you would see that. So once we make that observation and we notice that, we can simply conclude that let's get the negative of A. Okay, let's try to actually get the negative of A, and then we can compare better. So when we do that, we get a negative of A, and we get this. We first observe that it seems like there's a pattern here, and then after that observation, we decided to go and get the negative of A. So by the time we get that, we discover that, okay, this is exactly the same as this. The transpose is exactly the same as the negative of A. Okay, so in this case, we then say that A is skew symmetric. Okay, A is said to be skew symmetric. Okay, so that's what we refer to as a skew symmetric matrix. Let's move on to square matrix. So the square matrix, very important, a very, 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 very important concept when you're talking about matrices. Okay, so what is a square matrix? A square matrix is any matrix that has equal number of rows and columns. It's as easy as that. So if it has 2 rows, it has 2 columns as well. If it has 5 rows, it has 5 columns as well. If it has 6 rows, it has 6 columns as well. And no. So for example, we have A equals 3, 0 minus 2, 1. You can see we have 2 rows here and 2 columns. So this is a square matrix of order 2 by 2. The order here is 2 by 2. Then let's see B. We have 3 rows here and 3 columns. So B is also a square matrix, and the order here is 3 by 3. It's a 3 by 3 matrix. So that's that for square matrices. Now it's important to understand this because from the concept of square matrices, we have many other types of matrices that we need to understand. So let's move forward and try to understand them. So a singular matrix now. Let's talk about a singular matrix. Okay. Now we're going to talk about determinants as we move on, but let's just talk about this. Now if the determinant of a square matrix is equal to 0, then the matrix is said to be singular. So we'll talk about determinants as we move on. I'll introduce you to part of determinants, but take note of this, that when you have the determinant of a square matrix being equal to 0, then the matrix is singular. So let me just give you an example. We'll still talk about how we got this, but let's just look at this, and the answer here is 0. Don't worry, by the time we move on, so you should look out for determinants so that you will be able to get this better. So the determinant of this matrix here is 0, and it's said to be a singular matrix. Let's go to the next one. Okay, now triangular matrix. Triangular matrix. Now, triangular matrix is also born out of a square matrix. So you have to have a square matrix first. So let's assume you have this as your square matrix. Now, the elements A11, A22, and A33 are said to be on the principal diagonal. So this line is the principal diagonal. This line is the principal diagonal. Now, if the entries above the principal diagonal or below the principal diagonal are 0, then the matrix is called a triangular matrix. So when you say triangular matrix, this is what you mean. The entries above the principal diagonal or the entries below the principal diagonal are 0, then it's called a triangular matrix. Okay, are we good? So now let's talk about the type. So you can see this. The element, this is the principal diagonal, and the element above it is 0. This is the principal diagonal, the element below it is 0. This is the principal diagonal, the elements below are 0. This is the principal diagonal here, and the elements above are 0. Now, please take note that the ones with the zeros above, okay, are called upper triangular matrices, while the ones with the zeros below are called lower triangular matrices. Okay, so that's just the concept of a triangular matrix. Okay, let's move on to scalar. Okay, we're going to be talking a lot about matrices. Okay, so if you have a drink or something beside you, you can just take a sip. So scalar matrix. Let's talk about scalar matrix. Now, if the elements on the principal diagonal, remember that we're talking about all these matrices that most of them that we've talked about anyway. After we mentioned the square matrix, they are born out of the square matrix. So the scalar matrix 2 are born out of the square matrix. So if all the elements on the principal diagonal are equal and they're not 0, okay, they are equal and they are not 0, and all the other elements are 0, then that matrix is said to be a scalar matrix. Let's take a look at that. So for example, you can see this. The principal diagonal here, we have 3, 3. Remember, this line is the principal diagonal, 3, 3. And the other elements here are what? 0. And the elements here are equal and they are not 0. 3 and 3. So this is an example of the scalar matrix. This is an example. So this is a 2 by 2 square scalar matrix. I think you can just say this is a 2 by 2 scalar matrix because, for it to be a scalar matrix, we have already said that it should be a square matrix. Okay. So let's go to the next one. This is another example. You can see all the elements above and below the principal diagonal are 0. They are all 0. And the elements on the principal diagonal are equal and they are not equal to 0. They are equal to 2 and they are non-zero. Okay, so this is an example of a 3 by 3 scalar matrix. Okay, 3 by 3 scalar matrix. So let's go on to unit matrix. Now the unit matrix is born out of the scalar matrix. Now it's a type of scalar matrix. We said the scalar matrix, the principal diagonal, all the elements are equal and they are non-zero, right, on the principal diagonal, and every other element is 0. Now in the unit matrix, the elements on the principal diagonal are all equal to 1. They are not just equal and non-zero now. They are equal to 1. Now that matrix is called the unit matrix. So we have something like this. As an example, you can see 1, 1 on the principal diagonal, and every other element is 0 here. So this is a 2 by 2 unit matrix here. Then we have B, we have 1, 1, 1 as the principal diagonal here, and every other element is equal to 0. So this is a 3 by 3 unit matrix here. Okay, so that's that for the unit matrix. Now this is a lot to process. You don't need to start trying to understand everything at once. What you can do is you can familiarize yourself with these matrices by the time you have to work on them. So by the time you practice with them, you sit down and you make some calculations, you would say, oh yeah, this is a unit matrix. Okay, although this unit matrix, you're going to need it a lot. So this particular one here, you would easily get familiar with this. But as you practice more and more, you'll see, oh, this is a scalar matrix. Yeah, this is a unit matrix. Yeah, okay, this matrix is a square matrix because it has equal number of rows and columns. You understand? So as you practice more and you familiarize yourselves with calculations involving matrices, you get used to this, special matrices. Okay, so there's no need to panic. You get it as you practice. So let's go to the next thing. The unit matrix is denoted by the letter I. Now we're going to be using this by the time we're moving on in our next class to the inverse of a matrix and some other subtopics. So the unit matrix is denoted by the letter I. So when you see the letter I, it could be of the order 2 by 2, it could be 3 by 3, but once you see I, just note that that is the elements, or that's the letter used to denote the unit matrix. Okay, all right. Now the null matrix, from the word null, I think that's easy to guess. So a matrix whose elements are all 0 is called a null or 0 matrix. So that's the definition there, and it's denoted by the symbol 0. It's denoted here by the symbol 0. So examples of the null matrix, you can see this is a 2 by 2 null matrix. Okay, then and this is another 2 by 3 null matrix. This is a 2 by 3 null matrix. Okay, so just note that when all the elements in the matrix are equal to 0, then of course that's called a null or 0 matrix. Okay, so this is a tiny part of determinants that I said I'll introduce you to today. So let's just look at it together, and then we would move on in our next class to the remaining part of determinants, and we'll talk about simultaneous equations. But let's finish up with this class. So determinants, we're starting with the determinants of order 2. That's when you're talking about 2 by 2 matrices. Okay, how do you get the determinants? So given a matrix A, its determinant is given as, can you see that? How did we obtain this? Now, first of all, note that this slash, you can see this type of lines, they are used for determinants. You also use this when you're talking about magnitude in math or physics, right? So, but just note that you don't use this brackets for determinants. These are the brackets or the lines that are used for determinants. So how did we obtain this value? It's more like a cross multiplication in a way. So you're multiplying diagonally. You take the elements here on this diagonal, A11 times A22, and subtract the elements on the product of the elements on this other diagonal. So you can see we have A11 times A22 minus A21 times A12. Okay, so it's almost like a cross multiplication in a way, anyway, but it's more like multiplying elements on the diagonals and subtracting them. So this times this minus this times this. Okay, so let's take an example. Maybe that would help you better. So this times this minus this times this. Remember that? Okay. This should help you understand better. So let's take the determinant of this matrix. This is a 2 by 2 matrix. So let's take the determinant. What do we do here? We do put it in a determinant form, and then we say minus 3 times 4. Okay, minus 3 times 4 minus 2 times 1. Okay, so this diagonal, multiply the elements together on this diagonal and multiply the elements on this diagonal and subtract. So minus 3 times 4 minus 2 times 1. Okay, so principal diagonal, the multiplication of elements on the principal diagonal minus the other diagonal. Okay, so this would give us minus 12 minus 2, which would give us minus 14. Okay, so this is how you get the value for the determinant of a 2 by 2 matrix. It's not difficult, is it? I don't think it is. The one for 3 by 3 is a little more complex than this, but if you can understand the steps, you would be able to get it right. So let's just take a quick summary. We started with a review of our previous class, and then we moved on to talk about the transpose of a matrix, which involves interchanging the rows and columns. Then we talked about the different types of special matrices, square matrix, scalar matrix, unit matrix, null matrix, you know, so many others like that. So I want you to just take notes of the key things in each of those matrices. Remember that a square matrix has equal number of rows and columns. Then most of all the other matrices except from the null matrix anyway, because the null matrix can be, it doesn't have to be a square matrix, yeah. But most of all the other matrices are born out of the square matrix. For example, the scalar matrix and the unit matrix. On all those types. So it's important that you understand the different types of matrices, and as you move on in your calculations, you'll be able to identify, okay, this is a scalar matrix, or this is a unit matrix, or this is a triangular matrix, okay? And they have their different applications. You would see that as we move on. Then we moved on to talk about the how to get the determinant of a 2 by 2 matrix, which is very simple anyway. You just take the principal diagonal, multiply the elements together, and then you subtract the product of the other elements on the other diagonal. So I think that's the bulk of what we discussed today. So like I said, we're going to finish determinants in the next class, and we'll move on to how to use the this knowledge we've acquired to solve simultaneous equations. Yeah, it's a lovely concept which we will discuss in our next class. Now look at this. This home activity. You're to do this. You're to find AB, find BA. Now this number 2. Now it's more like a research. I put it here so that you could, try to study ahead, because I want you to, if possible, try to study ahead for the third order determinants. That's what we're going to. That's the second part of the determinant we're looking at. We talked about second order. That's 2 by 2 matrices. So this is a 3 by 3 matrix now. Just try, see what it's not compulsory that you get it right anyway, because I would get to this in the next video, but you never can tell. Try to figure it out. See what you could come up with, and see if you could, figure out the answer for that number 2. But we'll discuss this anyway in our next class, and hopefully we should be able to understand easily. So you could also visit quizzes.com and play some games on matrices and determinants if you're able to find some. Okay, if you're able to find some, but remember that you have number 1 to solve here. That's something you already know how to do, so make sure you do it. You can get back to me in the comment section with your answers. I'll be expecting them. So I think we'll stop here for today. It's been lovely taking you guys again today. Don't forget to tell your friends to like the video, share the video with them, and to subscribe. Yeah, so if you haven't subscribed, subscribe for updates so you could follow along with the class. Okay, so I'll see you guys again same time next week. I hope you continue to have a lovely day. Bye bye. Hello everyone.